Welcome to this episode of Tech Talk with Tom Griffin. I am Tom Griffin. At Tech Talk, we introduce engineers to technology trends, news, and product reviews. Today's technology trend addresses EMI filtering using X2Y EMI filters. Today we have a special guest on our show, Steve Cole, Senior Applications Engineer for X2Y filters at Johanson Dielectrics. Steve is going to address solutions for designs with EMI noise issues, as well as provide you, our Tech Talk audience, with a special free offer, which I will tell you about at the end of today's episode. So stick around. So Steve, tell us about X2Y technology.
Well, first, Tom, let's touch briefly upon two common misconceptions about these parts. Although the names sound very familiar, X2Y EMI filters are not X and Y AC rated safety certified capacitors. Secondly, while these look almost identical to three-terminal feed-through capacitors on the outside, when we look inside the part, they're far different. The X2Y component technology takes standard electrodes of ordinary two-terminal capacitors and surrounds them with an electrode shield structure very similar to a Faraday cage. The shield structure is connected to side terminals on the component, labeled G1 and G2. The result is a four-terminal, three-node component containing two matched capacitors in a package with extremely low equivalent series inductance.
So what advantages can this technology provide circuit designers?
So X2Y's multiple component options make it the multi-tool of passive components that really should be in every circuit designer's toolbox. X2Y is the only passive component that can provide both dual-line EMI filtering to reduce conducted and radiated emissions, as well as IC power bypassing to maintain power integrity. For EMI filtering, designers often utilize multiple components to create EMI filter solutions that are unbalanced when combined with PCB mounting parasitics. This could substantially eliminate the reduction of radiated EMI and increase susceptibility to RFI. In contrast, X2Y's balanced, low inductive performance, combined with its low parasitic layout, typically result in a single X2Y component doing the job of many discrete filter elements.
Wow, so this technology can reduce part count, real estate, pick and place cost, all with one device?
Exactly.
So aren't these also effective in power bypass applications?
Yes, Tom. That's the other main application for X2Y. X2Y's ultra-low mounted inductance make it a space-saving performer in power bypassing of integrated circuits. In complex bypassing applications, a single X2Y can replace up to 5 capacitors or remove troublesome impedance peaks of parallel decade value bypass cap arrangements, which are often specified by many semiconductor manufacturers.
Can you talk about some specific applications?
Sure, Tom. First, there's RFI susceptibility, where offending energy can couple through both IC signal and power pins. In this application, X2Ys have been shown to provide 18 dB microvolts reduction of high-frequency energy created by cell phones. That's a nearly 10 dB microvolt improvement over conventional capacitor filtering. We have a detailed application note on this at our website.
That's good to know. I'll put that link on our show notes.
In another example, we recently conducted some amplifier IC power bypass testing, where noise signals with very fast edge rates were injected onto the power lines of test circuits, and we compared conventional two-terminal MLCC filtering to X2Y filtering. Measurements at the IC VCC pins showed MLCCs let through 350% more noise than the X2Y filter.
That's fantastic.
So, where clean power is a concern to any engineers listening, they should take a look at the X2Y amplifier decoupling application note on our website. And finally, we're hearing from engineers about problems with noisy DC to DC converters. A typical engineering approach is to apply LC filtering in the kilohertz switching frequency of the device, but the noise spikes aliased on the switching frequency are actually in the hundreds of megahertz range, and that's the X2Y sweet spot. We've had very good results on both radiated and conducted EMI after applying X2Y filters on noisy, non-isolated DC to DC switchers.
So what other information does Johanson have that might be of interest?
We have a large number of app notes on our website, too many to mention here, but there's a couple I want to touch on. There's a detailed study on common mode filtering with compelling data showing X2Ys providing 10 to 15 dB improvement in high-frequency filtering compared to common mode chokes. There are 5 application notes on DC motor filtering, and that's becoming a very hot topic in both automotive applications and with handheld appliance makers, which must meet CISPR's 14-1 Titan EMI requirements. And we have a general application note on EMI evaluation and design guidelines, and that's really a must-read for any engineer ordering X2Y samples and about to test them out in their lab. And that's just to mention a few.
Okay, so what has the response been from the customer base?
Well, as you can imagine, it's been very positive. Engineers we work with are increasingly telling us that using X2Y has resulted in their quietest designs to date.
Well, that's fantastic. I really appreciate Steve sharing some of his valuable time and product knowledge with us today. If you would like more information on the X2Y EMI filters and additional products, visit catalyst-sales.com. Okay, so as promised, now for your free offer. Johanson is offering our TechTalk audience a free customized X2Y sample kit. Just go to catalyst-sales.com/X2Y kit offer to get yours sent to you right away. Thank you for watching this episode of Tech Talk with Tom Griffin. See you next time.